Okay, today we're going to do a short refresher on the triggering input on the oscilloscope, and I'm going to show you an example of one thing that I did in a recent development project that I had going, and show you just some things that made my life easier when I was doing this development work. The circuit that I'm developing puts out 4 different frequencies on 2 different channels. So what I do is every second I switch between 2 different frequencies on each channel. So in other words, on channel 1 I'll have frequencies A and B. On channel 2 I'll have frequencies C and D. So if for the first second of operation I'm putting out frequency A on channel 1, frequency C on channel 2. For the second of operation I'm putting out frequency B on channel 1 and frequency D on channel 2. And I flip between these 4 frequencies every second. Now if I try to look at the frequency of this waveform, now I can see the shape of it and notice it's a nice square rectangular waveform. I get a pretty good idea that my circuitry is operating correctly, but I don't know that my timing is right. So notice I'm trying to use the measure mode on this Handtech DSO 5202P scope and measure the frequency. Now this frequency is jumping all around between 8.9, 11.8, 11.9, 8.92, all the way, I think so what it does is it grabs a portion of one cycle and a portion of the next cycle and tries to average them together to come up with a number, which is pretty close, but it's not really good enough to let me know that I did what I wanted to do. A couple of times you'll see the number 10 show up. So again, I started to doubt whether my calculations were correct. So what I did is I decided to trigger off of the 1 second time base that flips between the frequencies A and B and C and D, and try to monitor them with the scope that I could try to settle it down. So the scope probe is now being given away as a promotion, a circuit specialist, with every scope purchase, and it comes in handy for an operation like this for 2 reasons. One is that it has a nice grabber to grab onto a place on your board that might have the signal that you're interested in. It's got a good ground clip that will reach pretty much across, at least my little board it does. And we know that it's a high quality signal with and it's not degraded or attenuated at all by the time it reaches the scope. So I'm going to go ahead. I had previously ran a wire out from this 1 second time base to my probe. So I'm going to go ahead and plug it up. And now I need to change the triggering to external trigger. If I go back to measure now, I'm measuring again in frequency, but notice that frequency is now pretty much settled down. 8.92, 8.928, that's pretty much where it's sitting now, 8.91. So within a couple of tenths of a hertz, it's settled down. It allows me to very easily now determine that indeed my frequencies are correct and as accurate as I need them to be. So this is just one use for triggering, obviously a triggering input on the scope, but it does show how this extra probe could come in handy when you're doing development work or any kind of troubleshooting, by providing you a good solid connection to your board and not have to worry about scrounging for wires and clip leads.